The rise of the Beam family began as a solution to a brutal geographic bottleneck that threatened the economic survival of early American settlers. In the late 1700s, the pioneers in the Kentucky Territory were drowning in a surplus of corn. The land was incredibly fertile, but the logistical infrastructure was non-existent. There were no railroads, and the cost of hauling raw grain over the Appalachian Mountains by wagon was so high that it rendered the crop essentially worthless by the time it reached the markets of the East Coast. Jacob Beam, a farmer of German descent, realized that the only way to move his harvest was to change its physical state through the science of distillation. By fermenting the corn and running it through a copper still, he performed a radical mass-to-volume reduction. He turned 1,000 pounds of bulky, perishable corn into a few gallons of shelf-stable, high-value liquid. This was the birth of the Beam Chemical Protocol, a system designed to condense the value of an entire farm into a single barrel. Technically, Jacob utilized the natural chemistry of the frontier to create a distinct spirit that would eventually be known as Bourbon. He relied on the high sugar content of the local corn and the unique mineral profile of the local water to fuel his fermentation. This was not a luxury craft at the time, it was a survival strategy. The whiskey became a liquid currency on the frontier, used to pay for labor, land, and essential tools. Inside his small wood-fired distillery, Jacob established the first iteration of the family fermentation logic. Unlike the rye-heavy whiskeys of the East Coast, Jacob's spirit was defined by the sweetness of the Kentucky soil. He had successfully bypassed the mountain barrier by turning his farm into a processing plant, creating a durable product that could be floated down the Ohio and Mississippi rivers to reach global markets in New Orleans and beyond. This era proved that bourbon was not just a drink, it was a logistical solution to a continental trade problem. The success of this operation allowed the Beam family to acquire more land and increase their production capacity, setting the stage for an industrial dynasty that would last for over 2 centuries. Every gallon produced was a testament to the idea that industrialization begins with the efficient conversion of raw materials into transportable wealth. The secret to the massive scale and consistency of Jim Beam lies in a specific mineral infrastructure located deep beneath the surface of Claremont, Kentucky. To produce bourbon at an industrial capacity, a distillery requires massive quantities of water that is chemically perfect for yeast health. The Kentucky limestone shelf acts as a natural subsurface filter of incredible scale. As rainwater trickles through the layers of calcium carbonate, it picks up minerals like calcium and magnesium, which act as essential nutrients for the fermentation process. More importantly, the limestone strips away iron, which would otherwise turn the whiskey black and bitter during the aging process in the oak wood. This geological filter is a permanent asset that the Beam family utilized to outpace their competitors. Inside the modern Jim Beam facility, this water is pumped from deep wells and managed through a system of high-pressure hydrologistics that ensures a constant flow to the mash tuns. The water temperature must be strictly controlled to ensure the yeast is never shocked or killed during the initial stages of fermentation. Technically, the limestone water allows for a high-gravity mash, which is the density of fermentable sugars in the liquid. The calcium helps the enzymes break down the corn starches into fermentable sugars with surgical precision. This is biological optimization at a massive scale, occurring long before the first drop of alcohol is ever produced. Without this specific water chemistry, the Beam machine would require expensive chemical additives to maintain its flavor profile. By building their distilleries directly on top of these limestone aquifers, the Beam family secured a permanent competitive advantage that cannot be replicated elsewhere in the world. The water is the silent partner in the distillation process, providing the mineral backbone that allows the yeast to thrive in high-volume environments. This era of the brand history saw the transition from a farm-based operation to a water-dependent industrial hub, where the geology of the land dictated the total output of the factory. The reliance on this natural resource meant that the distillery became a permanent fixture of the landscape, anchored by the very rocks beneath its foundations. In 1920, the entire American distilling industry was brought to a violent and sudden halt by the passage of the 18th Amendment. For 13 years, the production of beverage alcohol was a federal crime. This was a total industrial blackout that destroyed thousands of businesses. Most distilleries were dismantled, their equipment sold for scrap, and their intellectual property lost to time and neglect. James Beauregard Beam, better known as Jim Beam, was 52 years old when he was forced to shut down the family business. He spent the next decade in a state of logistical exile, pivoting to coal mining and citrus farming to survive the economic drought. However, Jim Beam performed a masterstroke of biological preservation that saved the company future. During the years of Prohibition, he allegedly kept the family proprietary yeast strain alive in his own home, treating it like a member of the family. This was a dangerous act of microbial custodianship that required constant attention and care. The yeast is the biological software that creates the specific esters and flavors of the bourbon. If that strain had died, the Jim Beam identity would have been erased forever, and the brand would have been forced to start from scratch with an inferior wild yeast. When Prohibition was finally repealed in 1933, Jim Beam did not wait for others to rebuild. At the age of 65, he raised new capital and rebuilt his distillery in just 120 days. This was a feat of high-speed industrial reconstruction that remains legendary in the industry. He did not just build a factory. He built a modern, volume-focused machine that was ready to dominate the new market. He recognized that the post-Prohibition market would be hungry for a reliable, standardized product that they could trust. By the time the first new barrels were filled, Jim Beam had transformed the company from a regional heritage brand into a national distribution powerhouse. His resilience ensured that the family 150-year-old chemical blueprint survived the greatest legal threat in American history, turning his own name into the primary symbol of the brand rebirth. This period proved that industrial leadership is as much about the preservation of core assets as it is about the construction of new ones. As the brand scaled in the mid-20th century, the old method of pot still distillation became a mechanical bottleneck that could no longer keep up with demand. Pot stills are batch processors that require frequent cleaning and have limited daily output. To meet the demands of a growing global middle class, Jim Beam invested heavily in the continuous column still. This was the transition from artisanal cooking to chemical process engineering. A column still allows for a non-stop flow of mash and steam, producing a consistent stream of high-proof spirit 24 hours a day, 7 days a week. This shift allowed the company to increase its production by several orders of magnitude while maintaining a level of purity that was previously impossible. Technically, the column still functions as a fractional distillation tower. Inside the tower, the fermented distiller beer is dropped through a series of perforated plates while high-pressure steam rises from the bottom. The alcohol vaporizes and is captured at specific heights, allowing the distillers to strip away unwanted harsh chemicals like methanol and fusel oils with mathematical accuracy. This is purity at scale. The modern Jim Beam stills are massive copper and stainless steel monuments that can process thousands of gallons of mash per hour. This high-throughput system requires a fanatical devotion to steam pressure management and thermal stability. If the temperature fluctuates by even a few degrees, the flavor profile of the new make spirit will drift from the standard, resulting in a product that does not meet the brand's specifications. The factory floor is a landscape of sensors and automated valves, all designed to maintain the structural consistency of the whiskey. This revolution allowed Jim Beam to produce a product that tasted identical whether it was bought in Kentucky, California, or eventually Tokyo. By mastering the column still, the company moved into the era of global commodity dominance, proving that the soul of the spirit could be maintained through the precision of industrial engineering. The true engine of the Jim Beam flavor is not the still, but the massive, unheated wooden structures known as rackhouses. In these buildings, the whiskey undergoes a mechanical interaction with charred oak wood that lasts for years. Unlike Scotch, which often ages in a steady, cool climate, Kentucky bourbon is subjected to extreme temperature swings throughout the year. This is thermal expansion logistics. During the hot Kentucky summers, the whiskey expands and is forced deep into the pores of the charred white oak barrels. During the cold winters, the liquid contracts, pulling the sugars, vanillins, and color out of the wood. This cycle repeats year after year, slowly maturing the spirit. Inside the Jim Beam rackhouses, which can hold over 50,000 barrels each, the whiskey is stacked in a vertical temperature gradient. The barrels at the top of the rackhouse experience temperatures that can exceed 120 degrees Fahrenheit, causing rapid aging and high evaporation. The barrels at the bottom stay cooler and age much more slowly. This is zonal maturation. Jim Beam utilizes this natural heat map to create different expressions of their bourbon by blending barrels from different levels. Technically, the wood acts as a chemical filter. The layer of charcoal inside the barrel created by firing the wood for a specific number of seconds absorbs the harsh sulfur compounds from the spirit. This is adsorption chemistry on a massive scale. The angel's share or the portion lost to evaporation is a necessary cost of this process, concentrating the flavors and creating the specific mouthfeel that defines the brand. The rackhouse is a passive industrial processor, using the rotation of the earth and the change of the seasons to perform the final and most important stage of the manufacturing process. The factory is essentially a giant wooden lung breathing the Kentucky air to transform raw alcohol into liquid gold. The placement of these warehouses is strategic, ensuring they catch the prevailing winds to facilitate the evaporation and oxygenation required for a perfect age. In the late 1980s, the bourbon industry faced a crisis of perceived value and a declining market share. Vodka and light spirits were dominating the market, and bourbon was seen as a dusty, low-rent commodity associated with an older generation. Booker No, the grandson of Jim Beam and the sixth-generation master distiller, executed a strategic industrial pivot that would save the category. He introduced Booker Bourbon, the first of the small batch collection. This was a move from volume-only production to high-margin craft engineering. He took the whiskey directly from the barrel, uncut and unfiltered, and sold it as a premium asset to a new generation of connoisseurs. This required a total rethink of inventory logistics and barrel selection. Instead of blending thousands of barrels to create a uniform mass-market taste, Booker began selecting specific honey barrels from the center of the rackhouses where the aging was most balanced and intense. This was curated distillation. Inside the bottling plant, this necessitated a small stream process where the whiskey did not go through the standard chill filtration, which is a process that removes fatty acids to prevent cloudiness but also strips away flavor. Technically, this was a move back to the authenticity of the source. Booker innovation saved the industry by proving that there was a global market for high-proof, high-character spirits that celebrated their industrial origins. This led to the creation of other iconic brands like Knob Creek and Basil Hayden, which used different mash bills and aging profiles to target different segments of the market. The factory floor was divided into mass production lines and artisanal finishing lines, allowing Jim Beam to dominate both the bottom and top of the liquor shelf simultaneously. Booker No proved that the machine could be tuned for complexity as well as capacity, ensuring the brand's survival in the modern luxury era. His work redefined what it meant to be a master distiller, turning the role into a public face for the industrial craft of bourbon. In 2014, the Jim Beam machine underwent a massive structural integration when it was acquired by the Japanese beverage giant Suntory for $16 billion. This created Beam Suntory, the third largest premium spirits company in the world. This was the ultimate marriage of American volume and Japanese precision. The merger allowed Jim Beam to utilize the sophisticated global distribution grid and total quality management protocols of the Suntory Group, which has a long history of excellence in the spirits industry. This was a move to ensure that the brand could compete at the highest levels of global commerce. Technically, this merger was about the cross-pollination of science and management styles. Japanese distilling is famous for its obsessive iteration and minute attention to detail, while Jim Beam is a master of high-velocity scaling and resource management. Inside the Claremont facility, this led to the implementation of Kaizen logistics or continuous improvement. Every stage of the process, from the moisture content of the corn to the char level of the barrels, was subjected to a new level of digital scrutiny and data analysis. This was information age distillation. The merger also allowed Jim Beam to expand its aged reserves by sharing warehouse technology and blending techniques with their Japanese counterparts. The global grid ensured that Jim Beam could be shipped to emerging markets in Asia and Europe with unprecedented efficiency and speed. The brand was no longer just a Kentucky heritage company, it was a data-driven global entity. This era proved that in the 21st century, the survival of a legacy brand depends on its ability to integrate into a multinational industrial network while maintaining the local biochemistry and heritage that made it successful in the first place. The collaboration between American distillers and Japanese engineers resulted in a more robust and flexible production system that could adapt to changing consumer preferences in real time. Today, the Jim Beam machine is a global industrial hybrid that balances 225 years of tradition with the requirements of modern sustainability and environmental standard. The brand produces millions of cases of bourbon a year, but the focus has shifted to closed-loop manufacturing and reducing the carbon footprint of the entire operation. The modern Claremont and Booker No plants are becoming digital green fortresses, utilizing anaerobic digesters to turn distillery waste into renewable energy and high-quality agricultural fertilizer. This ensures that the distillery gives back to the land that provides its raw materials. The industrial logic of the brand is now focused on resource efficiency and predictive analytics. Jim Beam is investing in precision agriculture to track the environmental impact of every bushel of corn and smart rackhouses equipped with sensors to monitor barrel health and evaporation rates in real time. This is predictive maturation, allowing the company to know exactly when a barrel has reached its peak. The seventh-generation master distiller, Fred No, and his son Freddie No, continue to manage the family yeast strain, which is still the biological heart of the operation. The factory has transitioned into a smart hive, where AI algorithms help the blenders predict how a barrel will taste 5 years into the future based on current climate data. Despite the high-tech sensors and the global corporate ownership, the physical anchor of the brand remains the limestone water and the white oak wood. The story of Jim Beam is a reminder that the most successful industrial machines are those that respect the natural variables of their environment. By turning a frontier survival strategy into a global manufacturing standard, the Beam family has created a liquid legacy that continues to define the American palate, proving that when biology and business are perfectly aligned, the results are truly timeless and globally dominant. The modern factory is a blend of computer code and copper, a place where history is recorded in every drop of amber liquid.